So for this class, all of the stuff, again, we're going to be using the virtual desktop. Now, don't worry about getting in the virtual desktop today. In fact, please don't try, because what happened was they created 50 of them, and they're building them right now. So there's probably a 25% chance that they've built yours. Okay, so you'll be able to get out there and take a look as far as go to here, and I'm in. But like we used to do, double click here, and you might get this to come up. If you do this and it comes up and it's totally blank, that means for sure it hasn't been loaded yet. I can tell you that right now. But I had the people try it this morning, and they put in the desktop, stopblackhawk.edu, and it came back in, and it recognized them, but said that you don't have permissions. So I asked Terry, and he said that's because we're still building them. All right. This virtual desktop, too, just so you know, has got a lot of stuff in it that wasn't in last semester. There's stuff that I put in it. I just wanted to show you this, not trying to waste your time or anything. And I know you can't see it, but at least if nothing else, in all seriousness, you're kind of a captive audience, just so you see the stuff that's in there. It's still going to have the Android stuff, or it's still going to have the Java stuff. Or I should say Java first, because that's what we're going to be doing tomorrow. So the Java stuff is there. You'll need it for Joomla. Just so you know, with Joomla is going to work so well with PHP because PHP powers Joomla. And what's weird with Joomla, I'm not going to get off on that because that's not this class. I get it. But just so you know, in Joomla, it's called a CMS. It's a content management system. Technically, there are no web pages in it. Technically, there's a humongous database, and it saves every page as a database record. All right? And you're going to see that starting tomorrow already. Yes. And I got a thing tomorrow. In fact, we're going to install that tomorrow. I didn't have him install the Joomla stuff. And the reason I didn't have him install the Joomla stuff is when you install it, you're going to be put in yourself in as administrator. And you're going to have to put in your login and your password. You put anything you want in there for a login and password. All right? When I grade your stuff, I won't need administrator access, but I'll need to be able to get into your machine to grade it. Does that make sense? Because otherwise there's not going to be too much I can do. But some of the stuff that wasn't here before, just so you know, there's a folder here that says software shortcut. I had them literally just put in. For example, jQuery is now here. You don't have to worry about downloading it. The jQuery UI, which is underneath here. All right, the user interface, which is all the graphical stuff, that's in there. Aptana Studio is in there. You may or may not know what Aptana is. It's literally... it's an editor that you could use. It's the free version of an editor you could use to put in HTML, to put in PHP, a lot of different kinds of different documents. Eclipse is still here. All right. I also had them put in Eclipse for PHP. As far as browsers, we've got Firefox, we've got Opera, we've got Safari, we've got Chrome, and IE are in here. All right. XAMPP is still here. We're going to look at that again tomorrow. Again, Eclipse for PHP is in here. There's also, because some people, I don't know where it is on here, but I know it's on here. There's also, if you decide you want to try to learn it yourself, there's NetBeans, which is another way that you can put in Java. So if you really hate Eclipse and you want to try to teach yourself, I've used NetBeans, but not for 3 or 4 years. All right, I found Eclipse easier to use, and that's why I'm teaching you it on Eclipse. But if you want to do that, you can. So there's a bunch of stuff that's out here in addition to all the usual suspects that we went through last semester. All right? All right. Let me jump back. I'm starting to throw stuff out on the P drive, just so you know. And as always, I'll make sure that when something is put out on the P drive, either every day or every other day, all right, as best I can, I'll make sure that I update Blackboard also. Out here right now, under the P drive for this class, under articles, not much. Under PDFs, there's a bunch of stuff that's out there. There's Objective-C stuff that's out there, and there, as you can see, and there's some C stuff out there. I'm not going to go through any of those. You can look at them as you have the chance or as you have the interest in doing so. If you say, I don't care, then don't do it. Homework will go here as always. Stuff we do in class will go here. That's pretty neat. That should have said 818, not 718. But Here's some stuff that's particular to Objective-C, and I have some Swift. I just don't remember where I put it. All right, and I'll have to find that. So I've got some Swift stuff. They're PDFs. But even some of the publishers that I use, they're all telling me, oh, yeah, our Swift book, yeah, it'll be early. It'll be out at the end of September. That's what they hope. All right. All right, as far as I should keep that up. The other stuff that's in there, so here's the syllabus. It looks like my standard syllabi. I'm not going to read it to you. If you do look in here and you look at the stuff that's in here, the stuff that now is in blue, all right, we're going to talk about secure coding today. And a lot of it with secure coding is just common sense. It's stuff you already know about. Things like when you're working with forms, just assume the worst. Don't trust anybody. Assume that all input is bad. All right, sanitize everything. Even if you're sure you sanitized it, make sure it's, and sanitize it, clean it, make sure both on the client side and on the server side. That's a lot of it. All right. So as it says, and this was back when I wrote the syllabus, because when I wrote this, it was at the end of May. There was no Swift. They literally announced it. Mac has a thing every year. I think it's called the WWDC, the Worldwide Developer Conference. That's when they announced Swift. I didn't know about it ahead of time. I've got a friend who teaches this kind of stuff in Madison. He didn't tell me about it, so either he didn't know or he knew and wasn't saying. I don't know. All right, but there should be 3 on here. I should have probably added at least get an introduction to Swift. You see the time, you know the room. There's 2 books. These books are good books. Neither one of them are great. And also, you may or may not have heard this. Notice out of stock. Guess why it's out of stock? Because the 4th edition was just released. The one that they told me, again, was going to be released at the end of April. That it was a month that ends with A, okay? And August ends with A too. So they released it in August because they were trying to have you get that book. And I said I will order it if you guarantee that by the time the semester starts it will be released. They could not guarantee that. Now as it turned out, it did. But there's not much difference between the 3rd edition and the 4th edition. I've asked them to send me the 4th edition, and I'll pass it around after they send it to me so you can see what I told you. So that's the one for the C class. Are we going to go through all of the stuff that's in here? Most of it. But a lot of it, I'm going to say like looping. Here's a surprise. C has the exact same looping structures that Java has. They work exactly the same way. Okay, now we're done with the looping part. Okay, we'll look at some code, but you'll notice that it looks just like so. I don't feel the need to go over a chapter on looping when you already understand looping. Okay, if statement, case statement, exactly the same as they are in Java, or a switch statement, exactly the same way they are in Java. All right, so we're not going to spend a lot of time on that. We'll look at programs that hold that stuff, but we won't spend a lot of time on it. Where we will spend time is where it starts to get a little bit different, is in Chapter 9. First, working with structures. And again, a structure is a record. And what's a record? Well, if you thought arrays were really, in Java, they were pretty strict, that's nothing compared to C. C is the most strict language I've ever seen with stuff like that. But what if you want to create something and you want to have information about a person? You want their first name, last name, or middle name, last name, address, city, state, zip, their salary, different kinds of fields. Then you put it in a structure because you can mix data types in a structure where you cannot mix them in an array. So if I wanted to create a record about each one of you, I would put it in a structure. So you're going to learn how to use structures. Then character strings. That will lead us into pointers. Okay? And pointers look a little weird. When you declare a pointer, you use an asterisk. When you reference a pointer, you use an ampersand. All right, so it'll look a little bit goofy when we start working with it, but we'll spend the most time on there. Most of this stuff, operations on bits. You all know what a byte is. A byte's 8 bits. In here, you can write things in C that are called like unions, which says check this field. If this field holds an integer value, make it an integer. If it holds a value with a decimal in it, make it a float. You get the difference? But you use the same bit of information to hold 2 different possible values. All right, that's called, typically when you use that, you're using a union. So if you want to be able to work with bits, so we're not going to talk much about that because you use that if you're doing systems programming, if you're writing operating systems and compilers. We don't really care that much about that. It's not that it's not important, but we're just not going to spend that much time on it. The processor rather, C, you have to do a few goofy things when you start writing C programs. By the time we get to that chapter, you'll know almost all the stuff that's in there. So we won't spend much time on that. Enumerations, you may or may not remember that from Java. When you create your own data type, we looked at a data type that was called day of week, and we gave it values Monday, Tuesday, Wednesday. You do it pretty much the same way in C. All right. Larger programs, the code that I worked with back when I was a C programmer at AT&T Bell Labs, I worked on what was called the 5 ESS, which meant version 5 of the electronic switching system. There were 10 million lines of code that were in there to run the 5 ESS. 10 million. And I'm not exaggerating. It was almost exactly. It was a little more than 10 million. As you'd guess, that wasn't all in one file. Okay, it wouldn't make sense for it to be all in one file. It was in multiple files that were included, etc., as necessary. That's what they're talking about here, I should say, with working with larger programs. So we'll look at that. Input, output, we'll look at, again, not spend a lot of time on it. Most of the stuff that's back here, I mean this, I can never understand when a guy writes a book that's got 19 chapters on it and makes chapter 18 on debugging. I always think that should be chapter 1 because people are going to make mistakes. So a lot of the stuff that's in there is common sense. All right, and then they start to get into object-oriented programming here, and they show you a C++ program. We'll look at it, but we'll spend no more than a period or so on it. All right. That said, when you look at the other book, table of contents, notice that this has got 21 chapters in it. I mean, do the math. If we say that we're going to spend about 6 weeks going over 21 chapters, that's 3 chapters a week. That's a lot of material. So I'm going to go over it, but what I'm going to do is rather than do that, a lot of it will be shown to you as you're writing these programs. And what's going to happen when we start doing this, because when you write Objective-C programs, by and large, you're going to write that they're going to be totally GUI. You're going to be using something called a storyboard. You're going to be dragging stuff all over the place. You're going to say, I like Visual Basic and C# better, but it's the same kind of thing. All right? And unfortunately, or fortunately, depending on your point of view, sometimes I'll say you can do it like this or you can do it like this. And guess what? If you check, there's 3 or 4 more ways of doing it. I'm not going to have time to show you 5 ways of doing the same thing. To me, that just doesn't make sense. There's not going to be time to do that. All right. So a lot of this is very basic stuff. This is the hardest part of the book. Not the last couple chapters, this. This is what differentiates using Objective-C from all other versions of C. Some of the stuff that you can do with it. All right? And we'll get into that. This right here, just so you know, this is writing a program. They have you write a simple calculator in Objective-C. Those last couple chapters. In fact, chapter 20 is like literally 4 pages long. Yeah. I'm going to show you that. You're not going to like it. Okay. But the good news is there's tons of free ones out there if you want to use a different one. The best ones, all right, you'd have to use Mike's machine because he's got Linux on it. Or I'd have to have him create another virtual machine for you to have Linux on it. So what I'm going to show you in just a bit is we're going to save it in Notepad or Notepad++, and then we're going to run it from a command line. Yeah. That's actually built into Visual Studio. Okay, so I'll show you that before the end of class today. The good news is when we get to the other parts, yes, we use an editor. We actually use an editor that's called Xcode. And it's people have asked me, well, is it as good as Visual Studio? It's different than Visual Studio. If you'd learned Xcode first and then learned Visual Studio, you'd probably like Xcode better. But since you already know Visual Studio, you'll probably like that better. But it's very graphical. All right, so we'll go through that. Like I said, then the other stuff, the Swift stuff, my hope is by that time I'll have more documentation. You can go out there right now, and I can type in Swift programming language. And I can, yes. And the best, this is supposed to be the best thing for it. It's out under Apple, but in order to do it, you've got to log in through your iTunes account. And I've got a thing into Apple because the last time I changed my password, I stupidly didn't write it down. So I kept using different variations of the one I had, and it locked me out, and it won't let me back in. And when I sent them an email, they just disregarded it. So I can't even get to that bit of documentation. If I get to that, I'll get it, try to save it in PDF, and make sure it's available to you. You know, you all know Tony from last semester who graduated last May. I've never met a guy who hates Mac like Tony did, because he couldn't say Mac without putting an F in front of it. All right? It got to the point where when I'd start lecturing, I would make sure I wasn't taping. You know, but he did very well. And he said, you know, I guess this isn't as bad as I thought it was. So, all right. This is the standard stuff that you've seen before. There's really nothing new in here that you haven't already seen. All right. So, what I'd like to do is I want to get in there and show you what a simple program would look like. Okay? All right, what I'm going to do is I'm going to come in here. Don't worry about writing this down or anything. All this stuff is either out there or I'll save it, make sure it's out there. But I'm going here. Now I'm on the virtual desktop. All right, I've already got some written. So here's some C programs that I've got written. Here's one I did yesterday. All right, and if you look at it, I mean, seriously, look at this. It doesn't look much different than Java. It really and truly doesn't. Until you get to the top of it. Where you do imports in Java, you do includes in C. All right. And now that you learn that, when you go to Objective-C, you go back to imports again. Because the difference in between using an import and an include, if you use includes like you have to do in C programs, even if it's already if I have another file here that already included the file, it includes it again. Import looks first to see if the file's already been included. And if it's been included, it doesn't include it a second time. But C doesn't support import. It only supports include. Okay? And this is basically stdio, standard input output.h. This says, when you use the brackets like this says that there is already a written, this is called a header file, .h. There's already a written header file that exists in the C system that somebody created for me and is available to me if I say stdio.h. If I create my own file that's called jeff.h, then I have to put it in oops, see the difference? The brackets imply that it's a system header. The double quotes imply that it's my header. And if I put it someplace else, I can do the ... star, etc. I can do all that kind of stuff as I need to do that. You're going to learn all that. It's really and truly not difficult. If you would look at this file, not that one because it doesn't exist, but if you looked at this file, you'd see a whole bunch of code in there that's already been written for you. Okay. Remember in Java we did a lot of system.out.println, and you may or may not remember this, but I also mentioned that Java not only supported system.out.println, it also supported system.out.printf. Printf they literally ripped off directly from C. Okay, and not only do they have it in Java, PHP also allows you to do printf if you want to. You hardly ever see it in PHP code, but you can use it if you want to. No, it's just that people just typically don't, but you can. And this is going to look a little weird, some of this stuff. Printf, so this will literally print right here. Please enter a calendar year between. Everybody see that? And these, this, and this are placeholders. Now as we start, one of the quirky things. D, double. No, D stands for decimal integer. So it's an integer. If you really hate it, instead of using D, you can use I for integer. So why didn't you use I, Jeff? Because almost all the application code you see out there uses D. But if you want to use a number that has a decimal in it, then instead of using D, you use F for float. Even if it's a double, you use F for float. All All right? So we'll be looking at that stuff as we go through there. So this is a placeholder, and that's a placeholder. And it says that value right there you use for this here, and that value right there you use for this. So it looks a little quirky, but it's just the way you have to write it. Now, what I've done is, if you notice up here, that's how you create constants. Remember in Java we would say static final. Here you use pound define. Okay. Let's say, just so you see this, because most of you, and Mark knows this already, but most of you will be in that class tomorrow. If I typed in this, define start year 2010, like that, that's how I define a constant in PHP. So you see they're all real similar. The syntax is a little different between them, but they're all basically doing the same kind of thing. Yeah. If this was a string constant, all I'd have to do would be to put it in double quotes. This is a string. Now it's all right. And this ain't JavaScript no more. So if you're working with strings, only use double quotes. All right. Single quotes means a single character. All right. So what does this do? So this is telling us to go in here, write a program that inputs the year that's between 2010 and 2020 and uses a for loop to produce a condensed, neatly printed calendar. Watch out for leap year. Okay? All right, so what do we have here? We're including our standard input-output header file. We're creating a couple constants. Every C program, just like every Java program, gee, I wonder where Java got that from, has to have a main in it. You can write this like this. You literally, sometimes you'll see it written like this. Just void main. If you've got void main like that, you can't return something like I am doing down, way down, 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 down. Here, I have to just say return. But it's considered to be better programming practice today to say int main, and if you're not passing anything in, to put in just void. And if you said why, it's because people who are much smarter than I am have deemed that's the way it should be done. All right, that's the best thing I can tell you. Like Java, this is block structured, so everything's within curly braces. That makes sense? Everything ends with a semicolon. Unlike JavaScript, must have a semicolon. Yes? Yes. That's something that's distinct to Notepad++. It'll try to help you. It'll have IntelliSense that it'll try to give you for certain things that you type in. It may or may not have. I don't really know. I don't remember. So what we're doing here, as you probably guess, is we're creating a bunch of variables. And the guy who was just really harping to his class last hour, the first year people, how you should document, didn't do a good job of documenting his variables. The names are okay, but I should have had comments there saying what they are. Okay? So this is a do-while loop. Remember those from Java, meaning it runs at least once? So it's going to say, please enter a year between 2010 and 2020. And then you put in the year. We'll go over that in a second. Then it'll check and say if the year that you entered was either less than 2010 or it was greater than 2020, it'll just ask you to do it again. Does that make sense? These programs will blow chunks if you put in something that's non-int for the value. Just so you know. It'll just blow up. And this is a bad blow up. Because typically what it'll do here at best is it'll lock up your system. And at worst, it'll put you in an infinite loop. So yes, you can make it not work, but don't do that, at least for a while, till we talk about how you can get around that kind of stuff. All right? Okay. I want to go back to this in just a second. But again, what is this saying? Well, check on the current year. So was it 2010 or 2011, all the way up through 2018, which should be the only valid values, but I put a default in there. That should never get hit, but just in case it does. All right, and what this is doing, just so you know, much like we did when we wrote the switch statements for JavaScript, we're putting in a line of code and we're breaking. Okay? You're going to like it when we get to Swift. Swift was smart. They said, you know, I'm sorry, pardon my French, screw these break statements. You don't need them anymore. It removed a lot of stuff that they thought were stupid. All right? And you write much shorter code, and it's so much more intuitive. Plus, it's got something called the playground that you're going to love doing. You can just type in your code, and on the right, it runs it for you, and it shows it to you. I don't think it blows up. I think that I'm not positive. I haven't tried that. All right. What this is doing is imagine Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. Everybody with me? Those are the numbers 1 to 7. So Sunday is 1, Monday is 2, all the way through Saturday, which is 6. This says that the first day of 2010 started on a Friday. The first day of 2011 started on a Saturday. Does that make sense? And I literally had to go online to look that up because I didn't remember. I couldn't tell you that kind of stuff. January 1st of this year was a Wednesday. Notice next year, Thursday, then Friday, then we skipped to Saturday because 2016 is a leap year. So this program does handle leap years. Now, there would be a way that we could do that, but I just hard-coded it in. Maybe that's not the best way, but I did that. All right? Now, let me go back and talk about this. This is how you do inputs. All right? And what's kind of cool about this is the first time you're working with pointers. This says what I want to do is I want an integer, and I want to put it in the storage location that's referred to as year. That says the address of year. Ampersand means address of. Asterisk, which we'll see when we get into that part of the class, means contents at that address. Now, I don't even expect you to remember that, but you're going to see it. Okay? And the program, if you want to make a permanent change, which is what we want to do here, you need the ampersand, like that. Except if you're using a string. Because with a string, the ampersand's implied. So if this was a string, so let's say, for example, I had a thing here that was a string, which I don't even want to get into with you. It's a character array that I said 25 name equals this. Okay? So if I wanted to read that in, and I wanted to read in a name, I'd say %s, but I don't use it then. I just would type in name. It's one of the quirky things about the language. Again, I'm not saying, hey, it's a quirky thing about the language. Do you like that, Mark? Because it's just the way that you got to do it. All right, so there'll be times when you'll ask me a question, and my answer will be because that's the way they did it. I'll take your question in just a second. Does everything that's going on in here make sense? You're telling them to enter a whole number between 2010 and 2020. Does that make sense? Then you're going through this switch statement here, and you're telling them right there, so up through that point, to figure out what the first day, where the 1 is going to fall under in this calendar. Will it fall under Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, or Saturday? Does all that make sense? All right. No, if it's a Boolean, oops, that's a real good question. Typically, what you would end up doing is you'd make it an integer field, which would have 0 for false and 1 for true. All right, and older versions of C do not support Boolean. You have to create your own using an enumeration, and I'm going to show you how to do that when we get to that point. All right, newer versions, and we're actually running an older version of C in here, believe it or not. I don't know why Microsoft put C84 on here, but they did. All right, and it doesn't support Boolean, the Boolean type. Notice if I type in bool, doesn't change color. Boolean doesn't change color. Boolean doesn't change color. It doesn't understand that. But we can create our own enumeration, and with that enumeration, we can create a Boolean type and give it values of 0 and 1. That's usually what you end up doing. All right? So anything that we've gone through in these lines up through here that doesn't make sense? I'm asking. Go ahead. Well, you can give it a new value later in the program. But what happens is when C is doing input, output, what it does is C bases everything off of addresses. So it's telling it to go to that address. It could care less about year. Year means something to you. It means nothing to the computer. But saying address of year says go out to that address that's associated with that, and you're about to change the contents that are in that address. When you can change something that's in an address, that implies permanence. That's one thing that C gives you, that Java gives you, but only indirectly, and most languages don't give you at all. If you remember last semester, we talked in the C# class, we looked at, you may or may not remember this, but when we passed variables, we sometimes passed them, we put reference in there. That was working with pointers. All right, in fact, VisualBasic.net calls it by ref if you're working with pointers, but it doesn't exactly let you use pointers. You can just sort of simulate them in their language. C is one of the most powerful languages there is, just because of the fact that it allows you to do that. And C, just so you know about it, it's literally almost 50 years old. Other than COBOL, I can't name another language that's used a lot that's that old. And the only reason COBOL is because there's 6 trillion lines of it out there, and they can't remove all of it. There's still a hell of a lot of software that's written in C. I would make the case and say if you can learn C and become a good C program, you can learn any language that ever has been invented. Any. All right? Because it's got some quirky stuff that it deals with. So if you can handle it, you'll be fine with any other language. No, the only thing, like I said, that'll happen is either your machine will lock up, or I can show you what'll happen in just a minute. I'll show you an example of that before the end of the day. All right. So you asked a question. That's kind of doing a Boolean right there. And all we're checking is the year divisible by 400. That's it. And I'm not worried about it. You could make bigger checks, but just keeping it simple. So this is saying leap year is basically a Boolean variable, then that's setting it to true and that's setting it to false. Does that make sense? And all Boolean is, just so you know, it's just an alias. That's what's happening behind the scenes. That's always what's happening. And I don't care what anybody else tells you. True or false. But the reason that they did that is in many languages, true is anything that's not 0. So you can set it to 87 and it's considered to be true. They wanted to give you more opportunity. C says it didn't want to do that. This should look to you just like a for loop that we have in Java. It's initialized the same way, tested the same way, incremented or decremented. What is this doing? Well, literally, January is 31 days. Leap year says check. If it's a leap year, in other words, if leap year is set equal to 1, it's got 29 days. Otherwise, it's got 28 days. You may or may not remember the question mark colon operator works the exact same way that it did in Java. March 31, April 30, May 31, June 30, July 31, August 31, September 30, October 31, November 30, December 31. And again, we should never hit this. This should be impossible to have happen. All right. Anything that's in there that doesn't make sense as far as what's going on? All right. Then this is just going to print out, you'll see this in just a second. We print out the pretty little calendar. All right. This is working literally with spacing. And this was a pain in the ass trying to set this thing up to have stuff actually line up. Okay. Now, you may or may not have noticed this, but this is a little different than before. Anybody want to guess what that is doing? What that number 2 in there is doing? No. You're close, though. Making it 2 places long. So in other words, what that'll do is whether it's 7 or 17, have it have the same amount of space that it takes up. But so your idea was correct. All right? And that's it. So let me show you this. So I've got this. I'll tell you what I'm going to do. I'm going to save this, but I'm going to save it to the desktop. That's fine. I saved it there, but I'm going to do a save as and just save it right to the desktop. All right, there it is. So you'll see it out there. Where is calendar? There it is. See, it's got its own little icon. Everybody see that? All right. Now, fortunately or unfortunately, for now at least, this is the way we're going to do this. So we're going to come in here under Start, and we're going to click No, I don't want to click. I told you wrong. I keep doing that. But we're going to go under Start, and then we're going to go under All Programs, and then we're going to find the Visual Studio folder. Kind of neat, and I give kudos to Terry for doing this. I didn't know if he'd have time. It's actually Visual Studio 2013. It's even newer than what you had, which was 2012. All right. Then if I click the folder here under Visual Studio, That's our icon. So if we could start Visual Studio, we don't want to start it. We want to go under Visual Studio Tools. I'll remind you again once we start doing it. And notice there's a whole bunch of these things. And I don't know what a lot of them are, but I just know that the first one works. So I come here, and I'm now at a command line. Problem is I'm on the C drive, and I want to get to the D drive. So I'm going to go to the D drive, go to Users, J. Scott, Desktop. There I am. If I type in here dir star.c, there's my program. Everybody see it? Calendar. When you compile a program in here, it's different internally than the way that it was set up, the way that we did it in Java. All right? In C, you've got to compile it first, and then you do what's called linking it. And when you're linking it, you're bringing in all those libraries like that std, Iowa that I showed you, and anything else. Java actually goes and interprets, and then it compiles. Here it compiles, and then it links. So when you want to run this, you got to type in CL, which means compile and link. Again, we'll go over this again. And then the name of the file, calendar.c. Now, before I do this, you see this? There's the file. Everybody see it? Okay. Now I'm going to come back, and I'm going to hit enter. I didn't get any errors. I'm going to put an error in so you can see that. And I'm going to put an error in so the program will blow chunks like I told you in just a second. All right. Now, to run this, first of all, notice it made our compile and our link files for us. See that? So it creates 2 more files. When you're all done and it all works, you can remove those 2 files. Don't remove this one. Jeff, I accidentally removed my C file. Well, then I can't help you. I'll say, Mark, type it in again. All right? So I want to run this. So now to run it, kind of like we did in Java, where you could from the command line, all I do is I type in the word. Notice it's calendar.c, so I just type in calendar. Please enter your year. You already saw that. Well, let's do this year, 2014. And you see what the program does? It just prints you out a little handy-dandy calendar. That's what the program does. Does that make sense? Now I'm going to go through here, and then we'll take a break, but I'm going to make 2 errors on purpose. First, I'm going to come through here in this file, and I'm just going to, on this line right here, I'm going to remove a semicolon. Over here, I'm going to remove, you can see it's \n for a new line. I'm going to remove that n. Let's see, what other good things can I do? I'll come in here, and I'll remove the double quote. I'll come through here, and I'll remove the equal sign. So I'm purposely entering some errors. Everybody sees that. I'm going to save it again. Now I'm going to come back. Now, if I went to run it again, it would still work because it's got the executable version in there. But I've got to come back now and compile and link it again. So compile and link calendar.c. And it's nice enough to show me errors. The error listing in here is not bad. It typically is really up there with a number that's involved, etc. Missing a semicolon. It'll be all stuff like that. All right? So it'll be all stuff like this. These are all the things, what I encourage you to do once we get into this, and it should be Wednesday, is we'll write a simple program. Or we'll look at a simple, then start doing this and making errors. That's how you'll learn. All right, so I just didn't have to go back and fix all that stuff, right? So what I'm going to do is, since I know this is garbage anyway, I'm going to remove that file, I'm going to remove that calendar file, and I'm going to remove that file, and I'm going to go back again where I've got the calendar that works. I'm going to copy it to the desktop. So again, this is the one that already worked. How do I know that? Well, I can do a compile and link again. Notice it works. And I can run calendar on it. Give me my year. Let's try 2010. And there it is. So that works. All right, but Mike asked the question before. Now I'm going to come in here and I'm going to purposely make a bad mistake in the file. Do I want to reload it? Yeah. All right. So I'm going to come in here, and hopefully this is the one that I didn't remove all the stuff from, but we're going to find out in just a second. But I'm going to come through here, and notice, for example, let's see. Okay, see how it asks me here to enter this? I already showed you what, I'm going to remove that. That's a bad thing to do, because the system doesn't have anything to equate this %d with. All right, so let's see what it does. It won't be good, okay? Oh, you make me a liar. It actually might have compile that. That's the right one. Let's try to run it. It may not be till when we run it. I don't know. Oh, that wasn't a bad mistake. I just left it out, so it doesn't. It's asking me for it. I didn't give it a value. You understand what I'm saying? All right. So that was an error, but not a bad error. I'm trying to give you a bad error. How about this? Let's say here we go. This one will work. Because this, how do I know this one will work? Because this is the one I should have showed you. Because this is what I did when I wrote it. See how it's asking here for 2 inputs? All right. I'm going to try this. I'm going to remove one of these 2. It will work. It'll blow up. Now I'm giving it 2 things, and I'm only asking for 1. So it shouldn't like that. I got to break out of this because I'm actually in a loop over there. So I've got to go back here and do it again. This is what will drive you nuts, is when you're working on this, the editor isn't bad. You get used to it. It's not great, but it's not terrible. But what you'll hate is when it locks up on you and you got to start it up again. Because then you got to come over here, and there's probably a way to do this, that you can change the default location back to the D drive, and then to users, J. Scott, desktop, etc. All right. So let's try compile and link now in calendar.c. Try it the other way. I'm going to put in 2 values, but I'm only going to put 1 in here. I'll leave the comma in and everything. Now that might just give me a syntax error. I want this program to blow up. First of all, notice that. What is that? Anybody know what that is? No. That's the garbage that's in the memory location that it happens to be going to. It's whatever happens to be there. It could be anything. All right, but I will tell you, notice it will not allow me to enter the value in there, 4,455,436. Let's see if I do this. It's funny because I know that I did one of these and it busted the other day. All right. Believe me, you'll have plenty of chances. Okay. I'm not sure why it's working because I'm putting garbage in here and it's still taking it. It's usually not this forgiving a system. All right. But I'll save all the stuff that I've done so far so you can take a look at it. Let's take a break. It's 3:57. We'll come back at 10 after 4 and we'll just look at some more. I'll try to see if during the break I can find a program that I